Let us look into this carrier sense slash CD. CD means collision detection. So what is a collision detection? See, normally it happens in such a way that, for example, if there are two stations and station A is sending a packet to station maybe BOC, at the same time the B also sending the packet. So immediately these two packets they collide at some point because they are using the same channel and they are sending the packet at the same time. So when this collision occurs, normally it immediately generates something called a jamming signal. And this jamming signal is sensed by all the stations which are connected to the channel. So immediately they back off for some time. Immediately they back off for some time. After some time, then they come back and they start transmitting the frames to their respective destinations. So this is the thing which we have to remember when you look into this collision detection. That means the collision is detected. Whenever collision occurs, the station automatically they come to know that the collision has occurred. It's quite simple. The thing is normally when the packet is moving, the voltage something approximately zero point 0.2 volts will be there. But when a collision occurs, it crosses 0.35, maybe sometimes zero point 0.4 also. That high voltage itself states that there is a collision on the line. So that is how it finds the detects the collision. That is called as a collision detection. So once there is a collision detection, the process is all the stations should back off for a momentarily, and then they can start sending the packets based on some strategies, whichever they are designed for. So you can see this, and the first attempt, whether it can use one persistent, so it can be non-persistent, it can be p-persistent. It transmits, okay, and if the collision is detected, if there's no collision, it's a success. Collision detected, a jamming signal comes, and when the jamming signal comes, all the stations they should back off, and then they start the second attempt, and this cycle goes on till the packet is transmitted. Now, of course, if it has some limitations here, you cannot cross more than 15. If not, it continuously goes to infinite loop, and that makes the entire channel totally the bandwidth. We lose the entire bandwidth. So you can see when there is a frame is coming from this side, a framing coming from this side. When these two frames collide, it moves from zero point 0.2 volts to something around zero point 0.4 volts or 0.35 volts approximately. That itself, this thing is sensed by the stations. So these are the things happen in case of CSMA. Yeah, what is CSMA, CA? CSMA, CA, and CD. CD means collision detection, CA means collision avoidance. See, the collision avoidance, see, the collision detection can be done normally only in wired networks. In wired networks, that can be sensed easily, but in wireless networks, we have the signal due to attenuation. The signal starts losing its what you call loses its energy one by r square. So once after transfer certain amount of certain distance, the signal loses its strength. At that time, even though collision occurs, that cannot be sensed by the base station. So the CSMA CD concept cannot be implemented in wireless communications. In wired communication, it's fine, but in wireless communication, detection of collisions is difficult. So they go for something called collision avoidance. So in collision avoidance means okay, either they have to uh, use the techniques which are controlled access. We look into that. So we have some diagram here. It's checking the carrier is busy, and when it's found idle, it is waiting for IFS interframe service. It waits for some amount of time, and then it starts continuation of window. We look into that later because this is basically a binary exponential algorithm. We look into that and sense the frame. That's it. So this is the flow chart. If the line is ideal, then if the line is ideal, it should not send, it does not send immediately the packet. It waits for some interframe space, and then only It's still iterative, then only it sends the packet. So if the collision occurs, it waits for maybe sometimes 2 hours. We have any algorithm for this. So basing on that, this loop goes on, but still more than 15 times it won't allow you. Yeah, collision-free protocols. These are quite important for this collision avoidance protocols. They need these collision-free protocols. What is the collision-free protocol? The first one is bitmap protocol. Bitmap protocol. In this bitmap protocol, it happens like this. The master, it sends a one, what is this called, a reservation frame. It sends a reservation frame. So if there are 10 stations and this reservation frame contains 10 slots. If there are only 7 stations, it contains only 7 slots. So first this frame is sent. So whenever this frame is moving on, if any station want to use the bus, it should reserve first. How it reserves? For example, this is meant for zero station. This is for 1 station, 2 station, 3 station, 4 station, 5 station, 6 station, 7 station. And if you look into here, 1 station booked the reservation, and third station booked the reservation, and seventh station booked the reservation. So these three want to send, others they don't want to send. So automatically what happens? Now 1, 3, 7 frames are selected. Okay, so after this, the first one is the first slot is taken by the uh, this no station number 1, and after that the second one is taken by the station number 3. After that the third one will send the frame, that is station number 7. Once these stations they send their packets, then once more the contention frame comes once more, and you have to reserve it. So this, since it's a reservation process, the question of collision doesn't arise. So there will be no collisions at all in this case. And this is binary countdown. In this binary countdown, what happens? Every station is having a address. Every station is having a some address. So in this example, we can see that the 4 stations they are broadcasting their addresses, and this station address is 0010, and the second one is 0100, 1001, and 1010. So these are the addresses they are broadcast by these 4 stations. Now what happens? First, they'll take this first 4. Okay, so 0011. In 00011, these 2 stations they see that the higher number means one number are there, so they give up. They they give up the competition. So finally, these two stand into the which one should get the channel. So in this, the second one is 00. When we come to third one, this goes the 1. When this the one is there is higher number, so this station give up. Finally, this station first sends the packet, and next time, whenever they want to send it, the same cycle rotates. So this is called as binary countdown method. Yeah. These are also controlled access only. So these sometimes they referred as scheduled access, sometimes they referred as controlled access protocols. Here we have another 3 different for protocols, and for example, if you look into this, the first one, reservation, is nothing but bitmap protocol. The second thing is polling. What is meant by polling? In case of polling, the master, the primary starts poll one after another. So it first selects the uh, it first polls it. It polls asks the A, and A is given negative acknowledgement. So then it polls B. B send the data, and of course it sends the acknowledgement. Means here what happens? The master starts polling one after another all the channels. So which one, if the station says I have a packet to transmit, so it allows it to transmit. If it doesn't have any packet to transmit, automatically goes to B station, and this goes on. So this comes under this polling. And the third thing is this one is quite simple, which is a token passing. So token passing is quite simple. A token is generated, and the token is passed from to all the stations one after another sequentially. Whoever station holds the token, it can transmit the frames, and after that it has to pass on the token to the next station. And this token, the token, it goes on rotating within this topology as like as a ring. So that is how the token passing works out. And of course, token management. Sometimes what happens, some stations, if they're defective in an interface card, the tokens might get corrupted or it might get damaged also. In those cases, another token is generated. There's nothing but token management. And we can see various ways of in bus ring topology. Even though it is a bus topology, you can see the tokens passing 1 to 2, 2 to 3, 3 to 4, 4, 5. And if you look into star, one sends to the hub, it goes to 2, from 2 it comes to 3, from 3 it comes to 4, 4 to 1. Same thing. And it's a jogging. So these are the various ways the token can pass between the stations. It's quite simple. Coming to channelization. So channelization, as we've seen that we have three different channeling techniques. One is frequency division multiple access. The second one is time division multiple access. And the third one is code division multiple access. What is a frequency division multiple access? The frequency band is divided into a number of bands. So each band is allocated to each station. For example, you can see it is having four bands. The top band is allocated to this, and the second band is allocated to this, and the third band is allocated to this, and the fourth band is allocated to this. It is something like you can take like this. If you take FM radio, we have so many channels between that 89 to uh, 89 to 94.8. In between, you have so many FM stations. Each and every FM station has a different frequency bands in the same sense. There's nothing but a frequency division, multiple access. And then comes the time division multiple access. Time division multiple access means you have you will take a one time this thing bandwidth and you start slicing into number of slot. One slot is allocated for one station. So for example, if you have a 10 MB bandwidth, so first 2 seconds you give to one station, another 2 seconds you give to another station, another 2 seconds another station, another 2 seconds, and this continues. It's nothing but slicing the bandwidth for between the number of stations. So this is a time division multiple access. And code division multiple access, this is a little bit complex procedure. uh, Here generally what happens, uh, a code is first should be generated. You can see here first we have a channel 1 and we have a channel 2 and we have a channel 3 and we have a station 4. All these stations are channels. And interestingly, all they use the same channel. And the most interesting point here is the division occurs not based on neither frequencies or neither time. This is totally based on codes. I mean to say, the example is like this. For example, if there are six students are sitting around the table, and two students they know Telugu, and two students they know English, and another two students they know Hindi. So at the same time, the person who knows Telugu can speak to another Telugu person. At the same time, the person who knows English can speak to another person who knows English, as well as the third one who knows Hindi with another person Hindi. Here the interesting thing is all the three pairs they can communicate at the same time, because the Hindi person cannot, the Telugu person cannot take the Hindi version, and vice versa. So this is the advantage here. All the things they mixed up, but only the station that can understand only their respective codes or respective languages. This is the simple way of explaining this code division multiple access. Okay, let us see the two subcategories which are there in the data link layer. As I said earlier, we have two things. One is media access control, which is referred as MAC, and the second one is LLC. You can see in this diagram, the media access deals with Ethernet address and frames and all these things, whereas uh, oh yeah, this is the data link layer, and you can see these things they deal with the MAC addresses, and the second part it deals with the logical link addresses. Actually, this logical link address only takes care of error control and flow control, and this MAC address takes care of uh, frame. And of course, we have seen this unreliable datagram, acknowledgement, and reliable. So this is the LLC field. It's having a back field, header field, and FCS field check sequence. These two things are the in between you have the payload. In this payload you have DSAP, SSAP, destination SAP, and SAP means service access point. So destination SAP and the source service access point, and this is the thing which is embedded in this. The entire thing becomes a frame. The frame, so that means the frame consists both the LLC as well as MAC. So that is the thing which they want to explain in this diagram. And of course, the media access, media access control. We already seen all these things, CSMA, CD. Actually, in this media access control, we have something called MAC address also. MAC address, media access control address, which is a 48-bit address